Okay, on Tuesday we started the topic of travel time studies. And another name for travel time studies is journey time service. So the main difference between a travel time study and a spot speed study is the length of the highway. Okay, so in spot speed study there is a limitation of distance. In travel time studies the distance should be longer. Okay, usually we take it between any 2 points. Then these are the applications of travel time data where we can use it. Then there are different methods or techniques for doing the travel time studies. One of them is called the test car method, in which you hire a car and the time is measured from inside the car. And this technique has 3 cases: floating car, maximum car, or average car. And you have to take care that you don't employ too many test cars at the same time. Another method is called the license plate method, in which you need 2 observers at the start and end point, and they are writing down the license plate number and the time. Then we have other methods. You can do the observations from a vantage point, a point of good visibility, and it can be done manually, or you can install a camera and later on take the observations from the camera. Then the test car can be used with devices so that the observations are not taken manually. The test car itself or the devices themselves will record the time and distance and speed and everything. Then I showed you some sample tables, both of them from the test car methods, because in test car you have more data available. For example, you can see the data for multiple points, okay, which can be done with test car. For each point you have the cumulative distance, you have the cumulative time. Then for each section you have the delay, the number of stops, the reason for delay, and so on and so forth. So all these things are possible with the test car method. This is an example from a local study, so this is a template which the ministry follows, and again you can see the points, you can see distance cumulative, time is cumulative, and the time is the watch time, the clock time. Okay, so they are not using a stopwatch, they are simply writing the time which the clock is showing at that moment. Okay, and the reasons of delay are also given. Now we will move on to some calculations. Keep one thing in mind, that travel time data does not require any new equations. Okay, so it's not like we had an equation for mean of spot speed, so we should have another equation for mean of travel time. There is nothing like this. Okay, whichever equations we have used for spot speed, they are also applicable for the travel time data. Okay, so no new equations needed. Okay, let us consider a hypothetical arterial. Hypothetical means what? What do we mean by hypothetical? Not real, right? Something imaginary, like your grades. Okay, this arterial has a mean running time of 196 seconds. Okay, and it has a standard deviation of 15 seconds. Okay, and like I mentioned, that the spot speed and travel time data will be dealt in the same manner, same analysis. Okay, one of the reasons both of them follow normal distribution. Okay, normal distribution means what? The bell shape, the symmetric curve, and so on. Okay, so since they follow the same trend, we don't need new equations. Okay, so what are they asking for? Find out average and 95% confidence interval of speed. Okay, they want average speed and 95% confidence interval of speed. So 2 things. Now average means mean, right? Average means mean. Okay, so how do I find the mean speed here? Tell me. Huh? Yes. Yeah, we have the time and we have the distance, right? And speed is distance multiplied by time, right? No? Sure? Why are you guys thinking? Okay. So how much is the distance? Tell me. 3 miles. Okay, so 3 miles. The mean time is given. Okay, they're asking for mean speed, so I will take mean time. Okay. And since the time is in seconds, if I keep it in seconds, it will get a very small number. So I'll put it in hours now. How much is that? Okay. For mean speed, I used mean running time. So for 95% confidence interval of speed, I will use 95% confidence interval of time. Clear? Okay, we are calculating the speed from time, right? Using distance and time. Will the distance change? Is there something like mean distance and 95% confidence interval of distance? Distance is same, it's the same highway, right? So distance will not change, only the time will change. And time always changes, right? So for 95% confidence interval of speed, I need 95% confidence interval of time. How do we get the 95% confidence interval? The equation was mean plus minus 1.96 E, where E was S upon square root of n. Okay, now what was S? Standard deviation. What was n? Number of observations. Do we have S? How much? 15 seconds is the standard deviation given. Okay. How about number of samples? Is it given? No. Okay. Now you have to look at the statement of the question and with the mean. What's the word they are using with the mean? True. True. Wherever a word true is used, wherever the word true is used with any statistic, that means it is for the entire population. Okay. In the earlier case, when we were calculating mean for the spot speed data, it was a sample, right? It was a sample. So from the sample, we were trying to see what will happen to the entire population. This mean is already given for the entire population. Okay, so it's not for a sample, it's for everybody. Okay, and now you can understand why they wrote hypothetical, because in real life it is not possible that you get a mean value which is for the entire population. It's not possible. You cannot give me a value for a real highway and say this is for everybody. What if a new driver is given the license tomorrow? You didn't include him, right? Or a new driver is born tomorrow. He will come on the highway after 20 years. We don't know, right? Clear? So this is a hypothetical case, and they are using the word true here. That means it's the entire population. Okay. So what was E? It was E upon square root of n, right? So now there is no n. There is no n. So E equals to what? S. Clear? Clear? Okay? Okay.
We must consider it as infinity.
What?
We must consider it as infinity.
And then A equals to 0. See? And then you will write 0. And then I will write my own 0. See? Okay, so but it's not like infinity. Okay, so because there's standard deviation, we do this because there is an error in the observation, right? This is what error in your observation. So if you are already taking the entire population, there is no error. So whatever the standard deviation is, this is the total variation you have in the data. Okay, this is the logic behind it, that we have a standard deviation in the sample, but that standard deviation is affected by the error of your observation. Okay, so in order to find out what is my error of observation, then I introduce E, small e. If there is no error of your observation, okay, because you already considered the entire sample, the entire population, then whatever standard deviation you are giving me, that is the variation in the whole data set. So I will use that one. Okay, actually using S here is the actual theorem. Somebody remembers the name of this theorem which gave us this equation? What was that theorem? Central limit theorem. So the actual central limit theorem has S here, standard deviation, because the actual central limit theorem is for the entire population, it's not for one sample. Okay, the actual normal distribution is for everybody, it includes everybody. What are we saying here? 95% confidence interval of what? Sample? 95% confidence interval of the entire population. The actual equation was actually with S here. The real equation which is given by the theorem is actually has S here. We replace S with E because we don't have the entire population. We only have a sample. Okay, so this is what we should have done if we already have the entire population. Okay, anyways, clear? Okay, moving on. So nobody will put zeros anywhere, right? No infinity, no 0. Okay, so now give me the confidence interval for time. You already know the mean of time. Okay, mean of time, not speed. And E equals to S, which is 15. So what is the confidence interval here? What is this? Mean is 196. Remember, mean of time. I'm saying mean of time. The standard deviation of time, right? 15 is what? Seconds, right? So put mean of time. Mean of time is 196. So how did this happen? You shook hands and it's spreading, huh? You will come tomorrow. Yes. He doesn't know. 10.
2 to 5.4.
2 to 5.4. Okay, and plus and minus, right? Okay, so I will calculate the speed, the confidence interval of speed now using these times, the same way I did here. Okay, so 95% confidence interval of speed. Okay, tell me. and okay. Any question, any problem? So the mean of time was given, distance upon time, mean speed. They were asking for 95% confidence interval of speed. So I will calculate first 95% confidence interval of time. Then using again distance upon time, I will calculate the confidence interval of the speed. Okay. And since the time was true time, that means for the entire population, then there is no sample and E becomes equal to S. Clear? Okay. Another example for travel time data, and the data is given in the form of a bar diagram. It's a bar chart. So on the x-axis you have the travel time values in seconds. On the y-axis you see the number of observations with that value. Okay. So how many vehicles had a travel time of 150? 1. How many with 160? How many with 170? 0. How many with 200? 5. Clear? Okay. Now again they are asking for average travel time and average of speed and 95% confidence interval of speed. Okay. So we have to find out for average speed we should have average time, right? And for 95% confidence interval of speed I should have 95% confidence interval of time. Clear? Clear? Okay. So as I already mentioned that we are not using any new equation. To find out the mean, we have used this equation in the case of spot speed. What was n? Small n. Number of vehicles, right? Where are the number of vehicles here? On the y-axis. Okay. What was s? No. Huh? It was the middle speed, right? Well, meaning the value which had the n, right? The value which has n. So these values are now given here. Okay? Because they didn't give us a groups. If they gave us a groups, we will find out the middle value. Okay? There are no groups here. They have already gave us a middle value. Clear? Okay? So I will directly use these values as my S here. What was capital N? Total number of observations. How many observations we have? 20, right? And what you are doing? Counting. Okay? You can count them as well. If this is not given, I am too lazy to remove this. So, for exam, I become excited and so on. Obviously, I will crop it out. So if you have to count it, then what do you count? The y-axis. Okay? Don't count the bars. Each bar has a value. You count the values. Okay? You count the values. So 1, then 1, then 1, then 2. Okay? So 1 plus 1 plus 1 plus 2 plus 5 plus whatever. Okay? So you count the value, not the bars. Okay? Clear? Clear? Okay. So give me the mean. And same thing with the standard deviation as well. We will need the standard deviation for the confidence interval. So we need the mean and the standard deviation. Capital N is 20, S from the x-axis, the capital S from the x-axis, and small n from the y-axis. First of all, you have to find out the mean. Okay, so after the mean you can find out now the standard deviation. How much is the standard deviation then? Huh? Okay. First of all, let us find out the average speed, because we already have the average time. So give me the average speed. How much is the length here? 3 miles. So this is your average time. Okay. Any problem till now? We just use the average time to find out the average speed. For the 95% confidence interval of speed, I have to use the 95% confidence interval of time. Okay, 95% confidence interval was mean plus minus 1.96 E. So first thing I need is E. Okay, in the previous question we said that we don't need E, we will just put S here. Can you do the same here? Why not? It's a sample. Okay, they didn't use our true anywhere, and we can see it's a sample. It's 20 values. Okay, so how much is E? Sure. 38.3 divided by square root of 20. Okay, now give me the 95% confidence interval for time. So it will be 218.5 Huh? Okay, then 95% confidence interval of speed. In the same way we calculated which one? The first one, the average one. So we just change the time. How much is that? Huh? 49 point. Average is 49, yeah. $53.5 and okay. So the travel time data was given. It was given in the form of a bar diagram, and they asked us for calculating the average of speed and the 95% confidence level of speed. So for average of speed, we will use average travel time. How to find out the average? The same equation which we have used for spot speed data. So the frequencies from the y-axis and the values from the x-axis. The total will be the, the value of the travel time from the x-axis. If you want the total number, then you should count how many values we have on the y-axis. Okay. So from the average, I can find out average speed. Then for 95% confidence interval, I need the e-value, and e-value requires the standard deviation. So first of all, I have to calculate the standard deviation, then the e-value, okay, and then you can calculate the 95% confidence interval of what? Travel time. Okay, and then using the 95% confidence interval of time, we'll do distance upon time, we'll get the 95% confidence interval of speed. Clear? Clear? Okay. Now this data is about what? Travel time. Okay. And what about this one? Which time is this? 11:30. Huh? Which time is this?
11:30.
Huh? What's true? No, after true. Everything is not true. After true, what is this? True what?
Running time.
True running time. Okay. So we have travel time and we have running time. Okay. Travel time is with delay. Running time is without delay. Okay. Travel time has delay. Running time doesn't have delay. Okay. So running time means the car did not stop. The time during which the car did not stop. So no stopping means no delay, right? No stopping means no delay. Okay. So the difference between the travel time and running time will be what? Delay. Okay. Stopping delay or just delay. Okay. So let's say the previous example, the time given in the previous example and the time given here, the data given here are for the same highway. Okay. So in the previous example, they gave me running time, right? Average running time. In this example, from the data, we calculated average travel time, right? So delay equals to what then? Tell me. Delay equals what? Travel time minus running time. Okay. So in this example, travel time average 218.5. Previous example, the mean running time was given 196. So your delay is how much? Clear? Any problem? Huh? Any problem? So this is one way of finding out the delay. You do a travel time study and note down the running time separately, and then you can find out the delay as the difference of these two values. Another method of finding the delay is using the probability or chance of delay. Using the probability or chance of delay. So let's say there is a highway. On that highway there are two signals. Okay. So if you don't stop at any signal, then you have zero delay. Okay. If you stop at one signal, the signal closes for, let's say, 40 seconds, around 40 seconds. Okay. So if you stopped at one signal, your delay is around 40 seconds. If you stop at both the signals, so one signal is 40 seconds and both signals is 80. Clear? Okay. But we know people arrive at the signal randomly, right? Somebody will arrive during green, someone will arrive during yellow, which is also green, right? Someone will arrive during red, okay, which has nothing to do with green, right? So this is the chance that you can arrive at both the signals during green. Okay, 56.9% chance, okay, or 56.9% people are those who arrive and they move during green from both the signals. So their stoppage is, their delay is 0 seconds. Okay. Then there are 30% of those people who arrive and at one of the signals they found the red. Okay. So for them the delay is 40 seconds. Then there are 13% people who arrive and both signals are red. It's a conspiracy against them. Right? Somebody doesn't want them to go to the class on time, right? That's why people are late. Yes. Clear? Now I want average delay. What should I do? Summation upon? Okay. Summation of this upon total, right? Sum these values divided by 3. Yeah? Yes? No? What is that? What? Times the probability. If you do summation upon the total, you are assuming that all of them have equal chance. This is when we do this. Summation upon total means all values have equal chance. But we can see this value has more chance, right? This value has less chance, and this value has even lesser chance. Okay? You cannot just do summation upon the value. You have to multiply with the chance of that value. Okay? So the delay in this case will be the value into the probability or the chance. Clear? Okay. So either you can calculate delay using the two types of studies, running time and travel time, or you can calculate delay using the chance of having the delay. Okay, so the value multiplied by its chance. How did I get these values? These are coming from observations. So you observe how many vehicles arrive at the signal and how many of them go without stopping. Okay, how many of the total go without stopping on both the signals, how many, okay. So if you observe like around 100 vehicles, so 30 of them only stopped at one signal, and around 13 of them only stopped at both the signals, and around 57 of them, the remaining, did not stop at any signal. Clear? Okay. In the next example, we have a series of travel time runs. Okay. A travel time run means a travel time observation. Okay. When with the travel time in the travel time topic or with the travel time data, whenever you see the word run, don't run. Okay. Don't run. I write run in the exam and you start running. Okay, we'll get the other hand broken as well. So you can run before the exam or after the exam, not during the exam. Okay, so run means an observation. Okay, so they want to make travel time runs, means they want to make travel time observations. For an arterial, they want to find out how many runs they need. How many runs? Number of runs means number of observations. Okay, they want to have a confidence level of 95% to be within plus minus 2, 5 and 10, and the standard deviation can go from 5, 10 to 15. Okay, now the equation which you see on the slide is the same equation which we have used for 95% confidence for spot speed data. Okay, we did the whole derivation there, small derivation there. Okay, but n is the value we want, number of observations, number of runs. Okay, what is s? Yes, what is s? The standard deviation. What is e? Tolerance, acceptable error. Okay, so what is the value of e here? Sorry, which value? 2, 5, 10. Yes, the one with the plus minus sign, because this is tolerance, so this has to be with the plus minus. Okay. Okay, give me the value of n for each case. Huh? 48. Sure. Okay, next. Which one? This one? This one? If you have exam tomorrow, you will be studying for the last paper, right? Give me the next value. What is this? 0.96 millimeter. Yeah, now since I calculated the 10 out of 10.
Not this one. 10 yes.
I know all of you have a virus, but the other value is the same. I'm trying to bring some order in my life. Tell me.
15 and 10, 1.7.
How much?
1.706.
What? Huh? Yes, come on. It's a simple equation. Come on. Anybody can do it.
Standard deviation 10 and error 5 will be 15.36.
This one?
Error 5.
Error 5. Error 5.
White nine,
Change
white
white
nine,
nine.
Means you told me one value. That is also wrong.
50.36.
Into 96. 15 to 216.
Now give me this value. 0.96.
54, 34.56.
34.56. Okay. Last one.
8.64.
8.64. Okay. Huh? Sorry.
and the negative values.
Plus
Square.
Yes, there's a square. Yes. Okay. Now, see this one. This has number of values, right? Number of observations. These are number of observations, right? I cannot take 3.8 for observation, right? So what would I do here? I'll take how many? 4. What about this one? 16? Not 15? Sure, everybody? Agreed? Why not? Why not 15? It's closer to 15, right? Huh? Yeah. So 1/3, we will not take, we'll just take 15. More accurate? Yeah. If you see here, when you increase the error, values are doing what? They are decreasing, okay? Because increasing the error means less accuracy. Okay? So when you will decrease the value, it will have less accuracy. This is the one which you need for this much accuracy. If you take less than this, then you are reducing the accuracy. Okay? So we cannot take less than required. We cannot take less than required. Even if it was 15.1, they still take 16. Okay? Because that 0.1 is required for the accuracy. You can do more than that, you will have better accuracy. Okay? Then you can see when the standard deviation increases, the number of values are also increasing. A standard deviation was a measure of dispersion, variation in the data. Okay? So if your data has more variation, you should collect more values to cover it. Okay? If you are only talking about sample of one class, then I may give you a good idea about that sample with 2 or 3 values. But if you are talking about sample of the entire UOB, then I need more values. Okay? You cannot tell me there are thousands of students, I took 3 values and this is the representation of the entire UOB. We cannot say this. Clear? Okay? So when the variation increases, you have to increase the number of values so that you can cover the entire variation. Okay. These are data from a test car. The values are given from point 1 for distance and travel time. All values are given from point 1 for distance and travel time. Okay, so these are cumulative, meaning from point 1. Then you look at the time. Okay, it is given as minutes and seconds because this is how the stopwatch shows you. Minutes and seconds. Okay, so in the field when you are recording the values, we don't look for doing conversion there. Okay, whatever is required, whatever conversion is required, whatever analysis is required, we'll do it afterwards. But when the value is shown to you, write it as it is, whether it is time or temperature or number or whatever. Clear? Okay. Then we have delay and number of stops, which is given for per section. So that means between 2 points. So this 10 seconds of delay and 1 stop is between these 2 points. this 30 seconds of delay and one stop is between these 2 points, 2 and 3. Clear? Clear? Okay. What we need to do with this data is find out, we'll not do the whole thing, or just do the first step. We have to find out the travel time, the travel speed and running speed for each section. Okay, we have to find out the travel speed and running speed for each section. Okay, so first of all, my sections. I have 1 to 2, then 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 7. To find out travel speed, I need travel time. To find out running speed, I need running time. But for each section, the travel time is given, but it is cumulative. Okay. So what's the travel time between 1 and 2? Same, right? No change here. Clear? Okay. For 2 to 3, this is from 1 to 3, 4 minutes 50 seconds. And from 1 to 2, it is 2 minutes 5 seconds. Okay. So to find out between these two, I have to subtract. How much is that? Yeah. Okay. So 4 minutes 50 minus 2 minutes 5 seconds. Okay. Clear? Okay. Next one. 730 minus 450. 320. 240. Who said 240? In your planet, there are 100 seconds in 1 minute. He is from a different planet, and unfortunately, we are in the same planet, so you have to follow him. Okay, so 7 minutes minus 4 minutes is 330. 7 minutes 30 minus 4 minutes means 330, right? And 330 minus 50 seconds is 240. Okay, don't try to make it easy. Okay, 1 minute has 60 seconds. Don't try to make it easy, huh? Okay, then 910 minus 730. 140. Okay, again 9 minus 7 gives you 2 minutes 10 seconds. Then 2 minutes 10 seconds minus 30 seconds. 1 minute 40. Okay, next one. 117 and 127. Is this your part-time job or something? Okay, what is the difference between travel time and running time? Tell me. The delay. Is the delay given? Okay, so we have the delay for each section, right? So there is no cumulation here. So you just take the value travel time, subtract the delay. Okay, so first one 2 minutes 5 minus 10. 195, right? 155. Okay, second one 245 minus 30. Clear? Okay, so you finish the table, bring these values on Monday. Sunday we have the quiz. It will be in your section. Okay, I cannot open quiz for 2 sections at the same time. Okay, so come in your section, whatever the problem is. I will start at the start of the section. Okay, so we will start at 11. Okay, after the quiz, I will give you the feedback on your term projects, the submission which you made. Okay, face to face. Yes.